So hello and welcome to our third part of the webinar series for smart motors. Today we would like to focus on Profinet. Profinet has been a standard for many years, and with our solution now we can cover lots of applications, and this is what we would like to show you today. Today, I would like to give you an overview over our products that have Profinet interface. Then I would like to show you some of the Profinet features. And then after the presentation of the products and features, my colleague Alex Haberstroh would like to give you an insight into commissioning. How do you basically get the motor running from connecting after connecting? What is the way with the TIA portal? Okay, let's start with the power range. Our power range goes from 20 watts motor up to 1,100 watts continuous and up to roughly 4,000 watts peak power. The motors with a power of roughly 100 watts and above DG45 have an integrated controller. The smaller ones don't have an integrated controller, but you can control them through our BGE 5510 external controller that is also able to control brush type motors like the GR42, GR63, and so on. Okay, together with the motors, we also offer gearboxes like warm gearboxes, Spiritech gearboxes, and planetary gearbox, a very wide range, and all designed by Dunkermotoren, as well as the brakes and encoders. And here it's quite important to note that we develop all these components in the same house, basically door to door. And so all the components are really adjusted to each other, and they really fit together from the first moment and are designed so that they fit to the motor. Now, the Pro functionalities, this is a Profinet IO device, and it is certified. So the certification means that we run, or the motor, and needs to undergo a really, really strict test. And only if it passes all these tests, then it can be called certified. This is important for you as customer, because you know if you get one of those motors, it will, under all circumstances, run in a Profinet environment. So there are tests like with heavy bus traffic or with wrong messages, how does the motor react? And if it passes all those strict tests, then it can be called certified. We also have a PROFIdrive as a drive profile, and here we support application classes 1 and 4. 1 is simple speed control, and 4 is real-time synchronous operation, which we support with our motors. And real-time, this is basically also the entrance of Dunkermotoren in the real-time world, because before that we did not support that. And so for real-time servo applications, we now have a solution. We offer the electronics as internal or as integrated or external version. The motors have field-oriented control. This is not only good for the low noise level, but also for a very good energy efficiency, especially if you have battery-powered applications. It's important that the motor efficiency is high so that the battery has enough power. We can run in interpolation mode, jerk and support jerk optimized ramps. All D-Pro Profinet have STO as a standard. And with the D-Pro functionality, we support also many IoT features. and we can do motion code programming. Motion code is basically little programs that run on the motor individually from the firmware. And with these motion codes, you can, for example, aggregate some data and send them out for predictive maintenance or similar applications. We also support SI interface, so you can connect external absolute encoders or any other encoders outside the motor, connect them, and the motor can position precisely to this external encoder signal. What we also support, this is a completely different story, because here we just provide the motor, is SIMATIC microdrive. Here, as I said, we provide motor with many different gearboxes and also with an encoder. And with microdrive, you have also speed and position and so on control, but you also have many more safety functionalities as described here on this page, which we do not have in the integrated version. So as I mentioned, we also support SIMATIC microdrive, and we help you, of course, to select the right solution. Okay, now how do you get to the best possible solution? First of all, we have our product range in our catalog. We have the internet configurator where you can combine thousands of different combinations with gearboxes, encoders, and brakes, and of course the motor. And for the technical data, we have the function and connection guide, which gives you all the information about wiring and what to do in order to get the motor running on hardware side. For the software side, for the programming and commissioning, there's a different help, and this is the so-called starter kits. With these starter kits, we provide of course, the GSDML file that describes the functionalities of the Profinet drive. Then we have the detailed parameter description and so-called Let's Connect commissioning guides. Let's Connect is a commissioning guide that helps you step by step to get the motor running. Parameter description, as you can see here, you have a comprehensive description of each of the more than 500 parameters of the motor, where you can optimize and tune the motor and get the best out of the motor possible. And the Let's Connect commissioning guides, they help you with really step-by-step descriptions, how you get the motor from basically switching on the commissioning computer until the motor runs. Everything is described in here, and so far we got feedback that you really should be able to have this as only means for commissioning a motor. And with that, you're done with commissioning, and how this looks in practice, we show you now. We have a setup here in our lab with TIA Portal, but also Drive Assistant. They are both connected to in the same Profinet network. As a controller, we have a Siemens S7 1500, and as a motor, a BG95 D-Pro PN. And yeah, Alex, if you could please show our viewers how commissioning works with this setup. So thank you from my side for now, and Alex, it's your turn.
Yeah, hello together. My name is Alex Haberstroh. I'm here at Dunkermotoren as application and service engineer since now over 3 years. And as Michael said, I will show you how to connect the motor to the Siemens PLC. So, as Michael mentioned, if you go to our website, you get the starter package. I have it here on my desktop, and it looks like this. There you have the GSDML parameter description and of course the Let's Connect. Like Michael said, we support PROFIdrive functionality, and if you want to use it, you just have to use the PROFIdrive Let's Connect. But today I want to show you the Quickstart functionality. Therefore, I open the Let's Connect, and if we have a small look into it, we see here some descriptions of the LEDs and so on, some general Profinet stuff, and then it starts. The first step, of course, is to import the GSDML file. On my PC, I have already done it, so I will skip this step, but I think you know how it works. But what we can do is to check if it's in the catalog. So let me open TIA Portal shortly and switch to English. So here under other field devices, Profinet IO, drives, Dunkermotoren, we can find our motor, and we can just put it and start with it. So the next step would be to get the connection between PLC and motor, and optional, you can also set up the topology. In my case, it is like this, I think. And then most important is to assign the device name. Just update the list, and hopefully if I switch on the voltage of the motor, then we will find the motor. Here it is. My motor has already the correct name because I always use this name for our motors, and I do not build every time a new motor when I set up something here. But you know, now you would have to assign the name and then just close the window. Okay, if we have a look into the Let's Connect, we have the hardware configuration, the assign name, we have the topology, and now, until now, it's the same if you do Quickstart or PROFIdrive. Now we have to set up the module for Quickstart. Therefore, we go into the device view of the motor, and then we choose here the application profile Quickstart. And if we have this module here, it includes the status register as input data and the 3 Quickstart objects as output data. Let's talk about what Quickstart means. If we go into the parameter description, we can have a look into the device parameters, and here we have the Quickstart device command. And the idea behind Quickstart is to have an easy way without any state machine or something to get the motor running. So you see here 10 commands where you can do the most important things like stop, quick stop, homing, velocity mode, positioning, and so on. But we have also a lot of other commands where you can do nearly anything with the motor, like set up the acceleration, deceleration, disable, enable, and so on. Later, we want to start a movement, and therefore we, for example, use the velocity mode, and we can use the command in hex 79. And for these, if we have a look into the 2 other objects, the desired values, here is described for any command which uses the desired value, what the desired value will mean. And in our case, for the command 79, Quickstart desired value 0 is used as desired velocity. So we later will have to use the object desired value 0 as target velocity and then write the 79 into the device command and the motor will move. Okay. So now we have this application profile here, but we still need the PLC tags. Therefore, we just create them. I just copy the names here. Status register. It's a double word. And let's see the address. It starts at 0 until 3, so it's okay. And then just a new line. And the commands, data 0 is the first 4 bytes. Data 1 is the next. Both are double words. Output starts at 0. And it starts at 4. And last but not least, we have the command, which is just a word. And it starts at 8. Okay, it's important at this time to compare these addresses here to the addresses of the module, but in our case, it looks perfect. In theory, that's enough to run the motor, but I want to show you some additional possibilities with the motor. First of all, we have the flexible mapping here. There you can add up to 12 objects in the cyclic data as input data and also 12 motor objects in the cyclic data in the output mapping. For example, we could use it for the position. If we have a look into our knowledge base, we have the position here, and the actual position is an int 32 value, and this is the name. I will copy it for later. So we want to read the actual position. Therefore, we have to use the input mapping. We choose a submodule in the fitting data type, put it over here, give it a name. Then we go into the properties of this submodule, choose here the right parameter. It already filters the fitting data types. So here we have the actual position. And then we have to set up an IO tag. We can just do it here. And that's it. Now we have added the actual position to the cyclic data. For the output data, we, for example, could use the digital outputs. I know that it's an int 8, u in unsigned int 8. But we can have a look here. It's down here, unsigned int 8. Just copy the name, paste it here. Again, create the IO tag and choose the right parameter, device IO digital outputs, And that's it. Now I can control the digital outputs of the motor via the cyclic data in our I/O tags. The next functionality we have, if we go into the properties of the motor, we have the module parameters. And here we can set up the startup parameters up to 64 parameters, which are always written when the motor is connected or when the connection is assembled between motor and PLC. And I will recommend to set up here the Profinet diagnostic. It's down here. If you write here a 1 into it, we will see it later. You can have text-based error messages in the diagnostic buffer of the PLC, which is quite helpful if you have, for example, an undervoltage. And then you just see field device error, undervoltage, and you know, okay, what do I have to do? I will have to switch on the power supply. Okay, but here you could add, for example, homing methods, acceleration, deceleration, other functionalities like the quasi-absolute encoder, which is a simulated absolute encoder inside the firmware, and many more. Now we have set up the startup parameters. We have set up our flexible mapping. We have set up the Quickstart application profile. And I would say now we can run the motor. So I will save it first, then compile anything, and download it to my PLC. Okay, that's it. And if we now go online, we see here that anything is green. If we to control the motor, I will have to go to a force table for a first view. Let's just set up here the Quickstart data 0 and data 1 and the command, and to be able to see that the motor is moving, the actual position. So if I go now, if I start the monitoring, we see here the position is 0. If I will rotate the motor a little bit, we see that the positioning is changing. And yeah, that's it. Now we can set up, like we said before, into the data 0, the target velocity. And if we, in decimal, please. And if we now write the command 79 and I force it, the motor starts moving. I'm not sure if you can hear it, but you see that the position is changing. And now the nice thing in Profinet is that we can have a look parallel with our drive assistant. And if we switch here to Ethernet, we see here the actual velocity, the position, and some other stuff. And for example, we would also be able to start an oscilloscope to record a picture of the movement. Yeah, so you can run this in parallel. Now let's see what happens if I switch off the power supply. Then we see here in the drive assistant that we have the error minus 1000, which is under voltage. And in the tier portal, if we go into the diagnostics buffer, we see here Dunker specific error code, hardware power supply under voltage. If we would not have enabled the diagnostics before, then we wouldn't have this error message here. Okay, so I think you did see how easy it is to control the motor via Quickstart and how easy it is to implement it into a new Profinet project. It's quite fast. And yeah, if you have questions, you can ask us in a few moments. And I think I will give the word back to Michael.
Okay, thank you for showing how to commission this motor. I think it's really straightforward and easy. And as Alex showed you just, you can have access to the motor through Drive System 5 and Tier Portal at the same time. And this is actually what I really like about Profinet very much, that you have this flexibility, that you can also interconnect with different possibilities. You also have the possibility to have a virtual world, exactly like the world in the tier portal. We will show it in the trade show SPS 21, where we will show you how you have the tier portal and the real trade show model interacting with each other and showing the similarities between the real world and the virtual world. Okay, so Drive Assistant has already been shown by Alex. You can do tuning with Drive Assistant as with all our other D-Pro and D-Move motors. And as you could have seen, you have the oscilloscope function, and you can change and read all the parameters of the motor directly in Drive System 5. Okay, so thanks very much for joining. And any questions you can ask now, or you can write them in the chat, or get in contact, or have a look at the website, or contact us directly, or myself for product-related issues, and Alex for commissioning and application and service-related issues. Okay, so thank you very much, and hope to see you soon.